Hi. Region is bounded by y equal to x square and y equal to square root of x, and you can see the region is shown here. So this is the y equal to x square curve, the parabola, and y equal to square root of x. So this one, the radical function is y equal to square root of x, forms the base of the solid. Okay, so for this solid, each cross section perpendicular to y axis is s square. So perpendicular to y axis, so this is the base. So this base is the side length of the square, right? So this is the square. So this length equal to this length, right? Okay. So now, what is the volume of the solid? Let's find the volume of the solid. So let's find the first the base. Here the base b equal to, so this is the difference between the right curve minus left curve. Okay, so that is the right curve is, this is the x values. Okay, so we have to express the right curve in terms of y. So that is y equal to x square is in terms of y x equal to, so that is the plus or minus square root y. But this part as in the first quadrant x is positive, we take x equal to positive square root y, and this one is x equal to the radical function. So this one equal to x equal to y square. Okay, so the left curve is x equal to y square and the right curve is x equal to square root of y. So the distance, the basic distance is the right curve that is this one x equal to y square, sorry, the right curve, this one x equal to square root y minus the left curve which is x equal to y square. So this is the base, and which is the side length of this square. So that is the square has the base length b and b, right? Now let's find the area of this cross section square. So area of the cross section square equal to, that is the b square, and b equal to square root of y minus y square. So b square is square root of y minus y square whole square, right? Now, okay, so this is the area of the cross section. So we can rewrite this as a of y, because this is in terms of variables in terms of y, right? So we can rewrite this as a of y, square root y minus y square whole square. Okay, now to find the volume, so we have the squares are, so this is the squares, we have to accumulate all these squares, right? From y equal to 0 to y equal to 1. Okay, so we have to accumulate all these cross sectional areas, we will get the volume. So the volume is integral 0 to 1 the cross sectional area a of y dy, right? And this is equal to integral 0 to 1 and the a of y equal to square root y minus y square whole square. This is equal to the volume integral. This integral gives us the volume of this solid, right? So now, so let's evaluate this definite integral, the volume integral. So we have v equal to integral 0 to 1 square root y minus y square whole square dy, right? So this is equal to, you can use this formula, a minus b whole square is a squared minus b square, a square plus b square minus 2ab. Okay, so you can rewrite this as a, you can expand this one, integral 0 to 1, so square root of y whole square minus minus 2 times, so ab, so that is the square root of y times y square plus b square is y square whole square dy. So this is equal to integral 0 to 1, the square root of y whole square is just y minus 2 times, here the radical can be written as a rational exponent y power 1 half times y square plus y to the power 4 dy, and this one equal to integral 0 to 1 y minus 2 times here the y power 1 half plus y power 2, this is the y power, so when the bases are equal we can add the exponents, that is the 1 half plus 2 plus y to the power 4 dy, and this one equal to integral 0 to 1 y minus, so 2 times, so y power 1 half plus 2 can be written as 4 half, so that the total is y power 5 half, 5 half plus y to the power 4 dy, right. Now here we can use the one formula, so that is integral x to the power n dx equal to, that is x power n plus 1 over n plus 1. Here the, if you take the with respect to y, you can do the with respect to y. If you take the y power n dy, you will get the same formula. Okay. Yes. Now, okay. So now let's evaluate this one. So use the, apply the formula. So integral, okay, so they apply the formula, so the integration of y with respect to y is, that is the y power, here the 1, so it is y power 1 plus 1 over 1 plus 1 minus 2 is the constant, and the integration of y power 5 by 2 is integral 5 over 2 plus 1 over 5 over 2 plus 1 plus y to the power 4, the integration of y to the power 4 is y power 4 plus 1 over 4 plus 1, 4 plus 1, and the limits are integral 0 to 1, and this is equal to y square over 2 minus 2 times, so here the y power 5 half plus 1, so one is the 2 half, so that is the 7 half, so y power 7 half over the 5 half plus 1 is, again we have the 7 half plus y power 5 over 5, 0 to 1, right. Now let's simplify this one. So y square over 2 minus, so 2 times, so here there is a fraction, 7 over 2 is the fraction in the denominator, right. So we can rewrite this as a, by uh, inverting this fraction we can multiply it, that is the 2 over 7 times y power 7 half plus y power 5 over 5 over 5, right, 0 to 1, and so this one equal to, this is y square over 2 minus 2 times 2 is 4 over 7 y power 7 half plus y power 5 over 5, 0 to 1. Okay, so substitute the limit. So when you apply the upper limit, so the 1 square over 2 is just 1 half minus 4 over 7 times y power 1 power 7 half is just 1 plus 1 power 5 over 5 is just 1 over 5 minus, when you apply the limit 0, so you can see all the terms contains y, so that becomes 0, right. And this is equal to, we have 1 half minus 4 over 7 plus 1 over 5, right. So now the LCD is, now the LCD is the LCD of 2 7 35, so that is the 70 is the LCD, right. So we can rewrite the, this one half as 35 over 70 minus 4 over 7 as the 40 over 70 plus 1 over 5 as, that is 14 over 70. So this is equal to 35 over 70, which is so the LC, the common denominator is 70, so we can add the numerator, so that is the 35 minus 40 plus 14. So this is equal to, so 35 minus 40, negative 5, negative 5 plus 14, that is the positive 9 over 70. So therefore the volume of this solid whose cross sections perpendicular to y axis are the 9 over 70 units.